Hello everyone, welcome to my P1990Conf section. My name is Yuying Song. Today my topic is how we reduce performance tuning time by orders of magnitude with database observability. Here is self-introduction. I am a database performance engineer at PingCap with 5 years experience of performance diagnostic tool design and performance tuning. Here's the agenda of today's session. First, we will talk about a pain point of a lot of software, why performance tuning is still hard even though software is well measured. And then I will introduce two methodologies. One is tuning by database time, the second is tuning by color, which is adopted by the database industry for decades, and how we apply it to improve TiDB's performance tuning and observability. And third, I will show you some user case, and you will know how the new dashboard help us to reduce the performance tuning time by orders of magnitude. Last but not least, I will also show you what else have we done to help our user enjoy tuning database and playing with it. Before we go through our topic, I'll show you some backgrounds. First, what is TiDB? TiDB is an open source NewSQL database which supports hybrid transactional and analytical processing workloads. It's MySQL compatible, and it features horizontal scalability, strong consistency, and high availability. The goal of TiDB is to provide users with a one-stop database solution that covers OLTP, OLAP, and HTTP service. Here is TiDB's architecture. First, it has four main components. The first is TiDB server, which is a SQL layer that is MySQL compatible. And then the second is PD server. It managed all the metadata. And TiKV server is the role-based storage of TiDB. And TiFlash is the columnar storage of TiDB. PD also manage all the metadata of where the data store in each storage nodes. And as for TiDB's monitoring framework, it adopts two famous open source projects. The first one is Prometheus. Second is Grafana. TiDB uses Prometheus to store performance and performance metrics, and use Grafana to visualize them. And here comes our first topic, why performance tuning is still hard even though software is well measured. Actually, TiDB is a very well software. Our developer and our community contributors spend a lot of time to measure our software. Almost every component has its own metrics, and every request almost every component has its own metrics for every request and operations. For example, this part in orange is the metrics of TiDB, and this part in blue is the metrics of TiKV. Take this one, for example, TiDB query. How TiDB processes SQL. First, it should get a tokens, and then it pass and compile the SQLs to process the execution plan, and then finally execute it. Each operations has its own metrics. However, does all those metrics help us to reduce the performance tuning time and help us to find the bottlenecks of the system easily? The answer is no before the TiDB 6.1 release version, because the significant pain point of our user or even our support engineer is that there are too many metrics in our system. You can see here we have almost 20 Grafana dashboard for each components, right? And each dashboard has a lot of rows and a lot of panels. And it takes our users, DBAs and support engineers, a lot of time to learn it and to dig useful information from all those metrics. It's very time consuming and painful. And in version 6.1, we introduced performance overview dashboard and apply two methodology in this dashboard. The first is tuning by database time, and second is tuning by color. Tuning by database time. Before talking about database time, we first talk about user response time. User response time have different meanings for different people. For example, if you are a DBA, user response time maybe is the query duration, is a SQL span in a database. But if you are an end user, after a browser or an application, the user response time for you maybe is you submit a request from a browser, and the request goes through the network to the application server, and the applications send some SQL requests to the database and get some data back into the application, and the application do some calculation and request more data from the database, and then finally return the result to the end user. The whole time period can be expanded, can be showed here, right? Only these two parts, marked in green, means the time you spend in a database. So when a user reports to you that the system is very slow, database is not things to bring to. The problems could be anywhere, right? So the first things for database performance tuning is to identify whether the performance bottleneck is inside or outside the database. And then when you confirm that the bottleneck is inside database, the time you spend in database is longer than the time spent outside database. And then the next things you need to analyze is database time. What is database time? It's the total amount of time TiDB takes to process application requests. You can use, there are several ways you can use to calculate it. First is you can use QPS to times average durations, and second is the 4 phases a SQL will go through in TiDB. First, you should get through. You should get the token, and then pass and compile the SQL, and then execute it. So the sum of all of the duration of these 4 phases equals to DB time. And third, you can use average active connections to times the time is also equals to DB time. The last one is because we use Prometheus to collect and store our metrics, so you can also use the query of Prometheus to calculate it. Tuning by color. Tuning by color. There are 3 important charts at the top of the new dashboard we created. We use different color to mark a different part of the database time in these 3 charts. We divided DB time into different dimensions. In the first chart, we name it database time by SQL type, and we divided DB time by different SQL type. For example, the time spent for select statement, we mark it in blue, and then those SQLs, those update SQLs, insert SQL, or commit SQL, we mark it in green. And why we use this colored? For write related SQL, we mark it in green colors, and for those SQLs related to read operation, we mark it in blue. And for others, we use other colors. For example, general. What general SQL means is that those SQLs is not related to the customer's workload. For example, when you use prepare statement, there are some SQLs like statement close, statement reset. That's SQLs that we named general, and those SQL is not customer workload related. So when you see general SQL take a significant part of this chart, it means there's something wrong of your system. The system is not used the most important resources to process the most important queries. It's doing something else. So, and then the second chart, for the second chart, we divided database time by SQL phrase. It's those 4 phrases we talked about before. We mentioned before: the get tokens, parse and compile the SQLs, and execute the SQLs. For this chart, for a normal workload or a normal situation, green should be take the most part of this chart. If you see some other colors, it means there's something wrong, or your system is not in a very optimal situation. It takes a lot of time to parse and compile the SQL and not execute it. And as for the execution time, because it takes a significant part of the whole DB time, we also divide it into TSO wait or KV request. This is the time we take to communicate with the PD servers and communicate with the TiDB servers. And also, we also mark those operations related to read operations in blue, and those operations related to write operations in green. So when you see other colors than blue and green in this chart take a significant part, there's something wrong in your system. For example, when there is a very serious lock contention or index contention in this system, the permitted lock may take a significant part in this chart, and you will see the chart in dark red light. And that's tuning by colored. So I will show you some example later. How the new dashboards help to reduce the performance tuning time by orders of magnitudes. Let me show you the first example. It's a feature testing of our small table catch feature. It's a feature we introduced in our version 6.0 to shorten our read latency. So in these 3 charts, we go through it one by one. For the first chart, you can see it's almost in blue, right? So this is a read-heavy workload. And there are two workloads here. You can see here. The first, we turn this feature on, and the second, we turn this feature off. And you can spot the difference in the third chart very easily, right? The color is quite different here. And for the QPS, you can see with the feature on, we have lower QPS, but with the feature off, we have higher QPS. But it's is a performance feature to to shorten our latency. But why we didn't we didn't improve our performance? And the third chart tell us why. You can see we know that the color we want is green and blue, right? The blue indicates the those requests about read operation, and green indicates those requests about write operation. But here shows brown, and because a lot of time was taken in TSO wait, and after we review our code, we find that because our developer didn't optimize the TSO wait reissues in this code path. So when we turn on the small table catch feature, the TSO wait issue occurred. So you can spot the bottleneck of this system easily with those colors. And then here comes our second example. It's a data migration scenario. The user wants to use AWS data migration service to migrate the data from Oracle to TiDB. However, you can see a very colorful picture here, right? A significant part of color was taken in pink and orange. The parse and compile operation make up nearly 60% of the DB time. And we couldn't use our prepare plan cache feature to cache our plan to reduce the parse and compile time. Why? Because the AWS database data migration service use query API to submit insert statement to TiDB. It didn't use the prepare statement API. So we failed to use our prepare plan cache feature to reduce the time spent on parse and compile phrases. With this feature, you can easily find the bottleneck of the system, right? Here comes the example of a social media platform. We can compare the time period of the same system, compared to time period of the same system. This is the screenshot of the normal system, and suddenly the customer report to us that there's something wrong with the system, and it gets quite slow. And with the colors, you can see that it's quite different, right? And there's some unusual light blue show up here, right? In a normal system, there are no light blue, but in this picture, the significant part was taken by the COP corporations, which was marked in light blue. And you can see a very noticeable red light here, which indicates failed query. So the first questions you should ask the customer is that why there so many failed queries show up in your system? Is there something wrong? Did you do some wrong operation? And the second is why there's so many corporations show up in this time period. And after analyze, we find that there are a lot of auto-analyze auto-analyze operations show up in the background. That's why the performance suddenly get worse. So with those colors, with these pictures, you can easily spot the bottlenecks of the system, right? And beyond performance overview, in order to help our users to use performance overview and performance overview dashboard and enjoy tuning TiDB, we also provide performance tuning guides based on performance overview dashboard. There are three significant parts of it. The first is performance tuning overview, which talk about the right way, which introduce a top-down approach for database performance tuning. And the second part is performance analyze and tuning. Last but not least, we show a very specific OLTP scenario and show you how to tune this scenario with performance overview dashboard. Now, here comes the key take notes for today's section. First, we introduce tuning by database time and tuning by colors, two methodologies that has been adopted by the industry for decades. And second, how it helps us to shorten the performance tuning time to articulate performance issues by numbers and avoid trial and errors. And because we don't have to dig in all those metrics of each components and learn each metrics of all those dashboards, we only use one Grafana dashboard, that's a performance overview, as the entry for performance tuning. So the requirements of human resources and expertise has been reduced by orders of magnitude. If you want to try our dashboards, here is the link for you to deploy a local TiDB cluster in 1 minute. So you can try to use it and try the performance dashboards. And we also provide some videos to introduce our methodologies and our performance tuning methods in our PinCap learning channel. You can get practice and get your hand dirty to try it by yourself. That's all for today. Thank you.